So today we will start a new module and a new chapter in your book that is regarding to the losses. In your book it is the chapter may be abstraction from the rainfall or something, right? That means the losses. Already we have seen what are the losses when we are doing the equation, the water budget equation. In that cases we have seen that incoming flow minus the losses will be equals to something. Now what will be that something? The something will be with respect to which you are finding the losses or you are subtracting the losses. Two equations were there. One was precipitation minus losses was equals to delta S, where delta S was change in storage. ठीक तो? So on that aspect we have seen that runoff was one of the losses, as because we are considering the amount of change in the storage. And another equation was there where we have seen the relation between the runoff and rainfall, the rainfall runoff relationship. In that particular equation we have seen that precipitation minus various sorts of losses was equals to runoff, or runoff R was equals to P minus L, precipitation minus losses. In that perspective, losses was including the storage as well, right? Now here, as because we are discussing about losses, we need to understand that in which aspect we will count the losses or calculate the losses, right? Those things we have to consider. While studying the India's budget, water budget, we have seen that we had a focus on what is the amount of water flowing through the river. If you remember properly, that I have calculated, not me, I have gathered the data where the calculation of flowing or amount of water flowing through the rivers and all was calculated, and basically that amount was called as the available water to us, right? So that is why we can say the runoff is our main aspect, and we have to calculate or we have to see what are the losses with respect to the runoff. Clear? So in engineering hydrology, runoff is the main important area of study. Hence the hydrologic cycle, any process in the hydrologic cycle, any process that does not contribute to the runoff will be considered as the losses, right? What are the losses there can be? We have already seen what are the losses there can be. Like major amount of losses is evaporation, right? One of the major amount of losses is evaporation. Next we are having transpiration. Then interception. What was interception? What was interception? The amount of water which are not able to touch the ground or before touching the ground it is obstructed by something, that may be building or trees or something, and from that part it is again evaporating to the atmosphere. So that amount is called the interception. Depression storage, as because we are considering the runoff as our main aspect, so obviously storage will be considered as the losses. Now next was infiltration. What was infiltration? What was infiltration? From this side, what was infiltration? The amount of water which actually intercept through the earth surface, right? The amount of water which is actually being intercepted through the ground surface, earth surface or ground surface, whatever, right? That is the amount of interception. Now we will study one by one losses, and we will see what are the factors affecting the losses. First of all, what is evaporation? I think all of us know about evaporation, right? Anyone description of or definition of evaporation? Not looking at the slide, obviously. Yes. So if evaporation means if change of formation from liquid to the gaseous forms, if it is changing the form from the liquid to the gas, but below the boiling point, right? Below the boiling point, obviously evaporation happens below the boiling point. So if it is happening below the boiling point, that will be considered as the evaporation. That phenomena will be considered as evaporation, right? And obviously we know that evaporation is nothing but one process where a large amount of heat, generally this amount of heat, that is 585 calorie per gram, this amount of heat actually used by those molecules which are changing the form from liquid to the gaseous form, right? And that is called the latent heat, right? So basic lintap, yes. So it is actually using the heat, so ultimately it is a cooling process. It is making the other body cool, right? As because is those molecules are absorbing those amount of energy from the body or from the environment or something, right? Okay. Now what are the factors affecting the evaporation? Those already we have studied in the school level as well, right? Now I will ask one by one if you are able to answer those relationship. First of all, vapor pressure. What do you feel? What will be the relation between the vapor pressure and the evaporation? The vapor pressure in what? What is the relationship between the vapor pressure and the evaporation rate? That is I am asking. So you are telling that it will be inversely proportional. So vapor pressure present in what? In the closed container. If it is closed container, obviously some time later the vapor pressure will be higher as because it is closed. So ultimately eventually after a certain time there will not be any sort of evaporation happening inside the closed container. So vapor pressure in the air, right, open air. So vapor pressure in the open air, if it is less, evaporation rate will be higher. One example. Do you wash your clothes by your own? Huh? না বলছো ঠিক লাইনে কিন্তু বলছো উল্টো। Have you ever seen that in today's weather or evening's weather, as because we are not having that amount of direct sunlight, right? Cloudy weather it is. So have you felt that the process of drying of those clothes are being large or something? Huh? Feel that na? Though the temperature related to this temperature in the winter, temperature is very less, but the drying process is faster. Yes or not? As because we are having a large amount of vapor pressure in our air. As because it is humid, you can see, you can feel it, right? It is humid. You are sweating, I'm sweating, that means it is humid, right? So a large amount of vapor pressure present in the air itself. The air does not need any sort of, obviously the rate will be lesser. Clear? Nextly, temperature. What do you feel? What is the relation between the temperature and evaporation? Higher the temperature, higher the evaporation rate. Directly proportional, okay? Wind. Huh? Higher the wind speed, higher the evaporation rate. Any example? As because if you see or feel the examples, then you can understand what is happening over there, and you are using that phenomena in regular basis. Yes, dryer, hair dryer. Hair dryer is one of the thing, as because you are blowing it, right? Another thing is there, that is when you are drinking some tea or coffee which is pretty hot, you generally try to blow it. Why? As because of the blowing, the evaporation rate will be higher, and then obviously the inside temperature of the any drink you are having, that is higher. So evaporation rate will be higher, and evaporation rate will be higher. That means that amount of energy will be absorbed by those particles which are being or changing its form. So eventually your tea or coffee, whatever it is, will be cooler in a faster way, right? Atmospheric pressure. Higher the pressure, higher the evaporation rate. Atmospheric pressure means what you are feeling right now. Actually, we don't feel atmospheric pressure, as because we are like made in this way, right? So the amount of pressure which is acting, amount of pressure acting, or amount of pressure which is given by this huge length of wind or air, that is atmospheric pressure. Indirectly proportional. Any example? He is saying directly proportional, you are saying indirectly proportional. Bolo. Any example related to that? Pressure cooker. Pressure cooker, right? Why we use pressure cooker? To boil it quickly. Why it is being boiled? As because you are increasing the boiling point. You are increasing the boiling point, right? So in any sort of hilly areas or something, they will be having a lesser amount of atmospheric pressure, so the boiling point will be below 100 degrees Celsius. So they have to increase their boiling point so that they can boil their food, right? So that is why they use those sort of pressure cooker and all, so that the boiling point will be increased, right? So what is boiling point? Actually a certain point in which it is changing its form. That means obviously is a phenomena of evaporation as well in a particular temperature. So basically that will be I guess that will be inversely proportional, right? Okay. And soluble salt is there, and heat storage in water bodies is also there. Now surface area is one of the factor as well, which is not written over there. Surface area of the water body, that is also one of the factor, and we know one example about that. While drinking and coffee or tea, we generally pour, if it is much hotter, then we generally pour it into dish, right? So we are making the surface area a large surface area so that the evaporation rate will be higher here, and eventually it will be cooler in a. Okay, now the relationship between the evaporation rate and the vapor pressure, which is presented in the air, that is equals to this, and that is given by Dalton, right? So this is eventually Dalton's law. What they are saying, that EL is what? The rate of evaporation in millimeter per day. That will be equals to C. C is nothing but the coefficient given by Dalton, right? And that will be equals to C multiplied by EW minus EA, where EW is the pressure inside the water body or the water mass in that particular temperature, and EA is the air pressure presented at, not atmospheric pressure, it is basically vapor pressure presented in the air, right? ठीक. Now nextly we are having the temperature, and they are saying the other factor, if the other factor remains same, then the rate of evaporation increases with the increase of water of the temperature. We have already discussed those things. Now why this is happening? Basically this is happening with respect to the temperature, the movement of the molecule of the water, it gets a high speed. The movement is will have a certain higher speed, right? So that after a certain time it will escape the body and it will form a vapor, right? So with respect to the temperature, the movement of the molecule will be higher, eventually escaping that body and being a vapor, right? Wind, the rate of evaporation increases with the wind speed. Already we have discussed those things, right? Atmospheric pressure, that is also been discussed, that is a decrease in that barometric pressure, that is atmospheric pressure, increases the evaporation rate. Clear? Nextly, soluble salt. We are having another point, that is the vapor pressure of the water is reduced when any sort of solids are dissolved. So if you are having soluble salt inside your water body, obviously the evaporation rate will be less. And heat storage in water bodies, that is deep water body have more storage, more temperature, obviously it will store more temperature, and the evaporation rate will be higher if if it is conserving large amount of temperature inside it, right? So if your water body is deep, evaporation rate will be higher. If it is not so deep, obviously that will be the opposite one. Now, how we can measure the evaporation? As because we need to find out what are the losses, what are the amount of losses, so that we can ultimately find out what is the runoff, or we can find out what is the budget, water budget, if it is matching the equation or not, right? So how we can find out those losses? Mainly loss is evaporation, I have already told you. So how we can find out the evaporation? As because it is not easy to find out what is the amount of evaporation was there. If you collect water in a rain, you can say obviously this is the stand of the rain, that means this is the amount of depth of the rainfall. You can calculate it. Eventually that is not also correct, but we can say something, or we can predict something out of it, that what is the amount of rainfall was there. But how we can find out what is the what is the amount of evaporation we are having? Similarly, we can store some water in a particular pot or something, where we know what is the amount of water present in the particular pot. Now after a certain time, we can see what is the change in the depth, the opposite one, right? We can see that. And if we are finding out what is the depth of loss there is, and that will be due to the evaporation only, so we can say that is the amount of evaporation per unit time. Area will be known, obviously. The pot is installed by you, no? Per area. Evaporation rate, when we were saying that what is the amount of evaporation, that means, so see, that is the problem. You cannot directly say this is the amount of water being evaporated from your large bodies as well. So on those cases you have to multiply some sort of factors, right? We will see what is the amount of evaporation in a particular pot, then we can say multiplying some factors or using some sort of empirical formulae that this is the amount of evaporation may be happening in this area, right? So that pot, basically that instrument, simple instrument it is, right? This is called evaporimeter. Evaporimeter, it's nothing but a pot, right? Those basically, that process is given over there, how we are doing that. Number one, what will be the process? That first of all, water is poured in a pan. I've already told you, a pan like structure will be there, or pot like structure will be there. Initial water level is measured by a hook gauge, whatever the measurement. You will see that that pan evaporimeter is there in our lab. You will directly see it, right? One graduated scale, nothing else. One graduated scale by which we can find out the depth, right? Water is added daily to keep the water level within a specified limit. Now I have already told you a process where we are finding out what is the change in depth. Now if you reverse the process, suppose you are keeping the level at the same level, that means you are adding some sort of water. So the addition of the water is basically your losses in the last day. Yes or not? I have already told you one process where we are pouring some water or keeping some water in a pan. After a certain time, we will go there and see what is the depth of change, right, in the water level. We can see that as well. Otherwise, what we can do, we can fix our water level in a certain time, certain depth, So to do so, what you have to do? After a certain time, obviously you have to pour more amount of water to keep the level at the same level, right? So they are doing that particular thing, right? So water is added daily to keep the water level within a specified limit. Evaporation is calculated from the change in the water level and the depth of the water level added. That is the amount of water you are adding, that is the amount of water which is being evaporated in the last time period, right? Pan evaporimeter thus obtained is converted to lake evaporation multiplied a pan coefficient, like what I have already discussed, right? In the last step you can see pan evaporation thus obtained is converted to a lake evaporation multiplying a pan coefficient. Huh? Pan coefficient means obviously that instrument will be having some sort of coefficient. I've already told you that some sort of factors will be there, and we will multiply that factor to find out what is the evaporation in a larger body. Lake evaporation means a larger lake, water is suppose a lake is there. So what is the amount of evaporation from the lake? So that is why you need to multiply some sort of pan coefficient to it to find out what is the evaporation from the lake. There are some sort of pan evaporimeters are there, and the descriptions are given. This is purely theoretical, and the process is there. You have to just see what is the difference between those pan evaporimeters, right? What are the dimensions? You have to remember those dimensions. If this type of question arise in your examination, then theoretical theoretical question is there. So in that particular case, you have to draw the evaporimeter, and obviously while you are drawing, you have to provide the specific dimensions to it. So you have to remember those dimensions. Now, to find out the evaporation, ultimately I have already told you that we need to find out what is the amount of evaporation, nothing else, right? So to find out the evaporation, we can use some sort of empirical formula or something, right? So the maximum of the empirical formula based on this equation, which is Dalton type equation, which is this one. What will be the amount of evaporation will be equals to this. This is given by the Dalton and Dalton type equation, it is called. So evaporation rate in millimeter per day will be equals to K multiplied by FU, right? K multiplied by FU multiplied by EW minus EA. Now what is EW, EA already we have seen, right? Now the remaining things are K. K is nothing but the coefficient, and FU is the wind speed correction factor. Obviously wind speed should be one consideration while we are finding out the evaporation, as because we have already seen that what are the factors which are affecting the evaporation. One of them was wind speed. There are other several formulae there, that is Mayer formula is there, right? You can see the Mayer formula is almost the same, but we are having a different factor over there, some different factors over there, that is U9. U9 is related to the speed as well, as because they are not considering the FU. Instead of FU they are using in bracket, they are using 1 plus U9 by 16. What is U9? U9 is nothing but monthly mean wind speed in kilometer per hour at 9 meter above the water surface. ওইটা ইউজ
ওই ফর্মুলাটা ইউজ করলে সবই দিয়ে
you can use anything, right? It is about your choice. Those formulas are there. If you feel that is the correct formula for you, you can use it. Those are the empirical formula given. And now some after various experiment or something, they are gradually evolving, right? So obviously the latest one should be the accurate one, but sometimes we may see that maybe the oldest one is being popular or mainly used in the practical cases. It may happen, right? It is about your experimental values, that this formula is correct or maybe near to correct. It is having a lesser error. Obviously each and every equation will be having error. We cannot define accurate value of evaporation, never, right? And Km, we are having, instead of K we are having Km for Mayer's formula, and that is also one sort of coefficient, that is equals to 0.36 for deep reservoir and 0.5 for the small reservoir. Now why we are taking two different coefficient, 0.36 and 0.5? As because we have seen that one of the factor of evaporation is the depth of the water body as well, right? Ross formula, everything's are almost the same, right? As because the difference is here is considering PA, which is actually the barometric pressure. Another factor has been introduced in this formula, barometric pressure. This is being considered right now, that obviously it is one of the factor. And instead of U9 we are having U0, same thing, right? That is the kilometer per hour wind speed in kilometer per hour at a ground level, or 0.6 meter at the ground level. Nextly we are having water budget method. Now water budget method, you can see this water budget method, nothing is there, right? The same equation is there almost, right? Okay, energy balance method, mass transfer method. Next we are having another thing, that is called the transpiration, the second factor, transpiration. And what are the factors affecting the transpiration? I have already discussed that what is transpiration. You also know that the phenomena by which the tree leaves, from the pores of the tree leaf, water being evaporated in the atmosphere, that is called transpiration. And what are the factors affecting the transpiration? The factors affecting evaporation will be equal to the factor affecting transpiration. হ্যাঁ কি বললেন? নাম্বার অফ, না না সেটা তো একটা বটে। ইফ ইউ আর কনসিডারিং আ পার ইউনিট এরিয়া, then what is the rate? The rate of transpiration will be affected by the same factors which are actually affecting the evaporation rate. Clear? Now basically we do not calculate in a particular area where the trees are there. We do not calculate evaporation and transpiration separately, but combining those two we find one thing, that is called evapotranspiration. Evaporation and transpiration together, it is evapotranspiration. So while transpiration takes place, the land area in which plant stands also lose moisture. So if you are having trees obviously standing on land, so from the land itself evaporation is occurring, and from the leaf itself transpiration is occurring. So both the phenomena is happening in the same time. Hence, for irrigation, it is considered advantageous to consider evaporation and transpiration process under one head, and that head will be called evapotranspiration. Right? Now, evapotranspiration, ET, or consumptive use, CU, is the total water loss from the agricultural land. That will be the total amount of loss with evaporation and transpiration, right? Now, obviously, the factors affecting the evaporation is equal to the factors affecting transpiration. So, obviously, those factors will be affect evapotranspiration. The factors will remain same, right? I've already told you the factors which are affecting evaporation, and I've already told you that those factors are also affecting transpiration. So, together the factors will be same. Now, one another thing is there, and one another definition is there, that is called PET, potential evapotranspiration, and this is given by, the definition is given by like this, that if sufficient moisture is always available to completely meet the need of vegetation, fully covering the area, the resulting evapotranspiration is called the potential evapotranspiration. That means what? Obviously, if there is no water or less water present in your land for the vegetation, obviously evapotranspiration will be less. And if it is higher, the evapotranspiration rate will be higher. But there will be one limit, na? There will be one limit. The evaporation rate is something, it is having some limit, transpiration rate is something, and it is having some limit. Together, if you pour a large water or provide large amount of water to the vegetation, obviously after a certain time, that rate will be fixed at a certain point. That maximum evapotranspiration is called the potential evapotranspiration. That means if the water is fully available to the for vegetation, then the maximum amount of transpiration, evapotranspiration, that is called the potential evapotranspiration. Now, what is actual evapotranspiration? The definition goes like this, that if sufficient moisture is not available, the real evapotranspiration occurring in the specified field, that is the actual evapotranspiration. Already I have told you, if no water is present, obviously no evapotranspiration will be there. If you gradually increase the water, obviously the rate of evapotranspiration will be higher. Eventually, after a certain time, the evapotranspiration rate will be fixed. If you add more amount of water, it will not affect. That maximum is the potential one, but maybe in your field the maximum amount of water is not available for the potential evapotranspiration. The amount of water present is somehow less. Suppose if this is the case, then the amount of evapotranspiration occurring in real time, that is called the actual evapotranspiration, AET. Another definition we are having here, that is called the field capacity. Field capacity, right? It is the maximum quantity of water that the soil can hold against gravity. The higher moisture input to a soil at field capacity simply drains away, right? So each and every type of soil is having some particular holding capacity. It cannot contain a larger amount of water than particular holding capacity, right? If you pour more and more water, obviously it will be drained out. That amount of water that maximum amount of water which can be held by the soil mass, that is the That is the field capacity. Permanent wilting point. It is the moisture content of the soil at which the moisture is no longer available in sufficient quantity to sustain the plants. क्या समझ आया? हाँ, due to the presence of moisture, right? So your plant is having some sort of capacity as well to withdraw the water from the soil. Clear? Simply imagine something, right? That some portion of water present in your soil, but the plant is not having the capacity to withdraw or absorb that amount of water from the soil. If you increase the water content in the soil, it will try to soak it, and eventually after a certain limit it can soak the water from the soil. That limit after which it can soak, or in opposite direction, if you see like this one, after which limit in the decreasing water, beyond which below which limit it cannot soak the water from the soil mass. Obviously if it is not getting any sort of water, it will die. The vegetation will not sustain, right? So that limit is called the wilting point, permanent wilting point. Now you can find out the difference between those two, na? FC, that is the field capacity, and PWP, that is the permanent wilting point. You can find out the difference between them. Field capacity is the capacity of the soil to hold the moisture, and PWP is the capacity of the plant, beyond which or below which it cannot extract, the root cannot extract water from the soil mass, right? Now 4 definitions were given, right? 4 definitions were given to you. Potential evapotranspiration, what was that? Potential evapotranspiration, what was that? Or go. Potential evapotranspiration, what was that? শোনোনি, শোনার ইচ্ছা নেই, তাই তো? উদিত, উদিত না উদয়? উদিত, হ্যাঁ বলো। আচ্ছা, so potential evapotranspiration, I have already told you that if a sufficient amount of water is present in your field, then obviously the maximum amount of evapotranspiration will be occurring, and that will be called the potential evapotranspiration. Actual evapotranspiration, which is actually occurring in your field, that may happen, it may happen that কোথায় না, that doesn't mean it is not having moisture. It means what is actually real in your field. it may happen that your field is having a maximum amount of water and maximum evapotranspiration is occurring in your field. That means maybe right now your AET is equals to PET. It may happen, but obviously AET cannot be greater than PET, and because it is maximum. AET can be 0 if it is not no water is present in your soil. Obviously, no evapotranspiration is occurring. So AET is 0 in that case. That may happen as well. Nextly, we have seen another formula that is called field capacity. That means the amount of water which can be withheld or hold by the soil molecules or soil particles. Right? That is the maximum amount of water. And another thing we have seen, that is called PWP, permanent wilting point. That is the amount of moisture content below which the roots of the plants cannot absorb the water from the soil. Right? Those are some moisture content. Field capacity is one of the moisture content, one sort of moisture content, and the permanent wilting point is another sort of moisture content, you can say. Right? Now, if the definitions are clear, then you can find out or see the visualize those relationship. Oh, the first relationship is that one which I just told you, that if a sufficient amount of moisture is available in your field, then AET is equals to PET. And another thing is there, that AET will be greater than lesser than PET or equals to PET maximum, right? It cannot be greater than PET. Now to find out PET, some again some formulae are there, empirical formulae are there. You can just see those formulae, as because I don't feel that this sort of example will may come in your exam, but though you should see those equations. If those sort of equations are, or those sort of question is there in your exam, obviously all the data will be given to you, right? Other than that, you cannot find out. Interception, we know interception definition is given only, right? And the definition is already given in the initial portion where we were discussing about the various losses. In that case, we have already told you the what is the definition. That definition is given. Infiltration, again the infiltration definition is firstly given, then some experiments will be there by which we can find out the infiltration. Okay? We will see this thing in the next part. You can take one break right now.